My name is Rebecca Dickinson and I will be conducting a presentation on the human immunity. The areas covered will be the first, second and third line of defence, specific immunity and the biology of vaccination and the conclusion. Introduction. This presentation will outline the human immunity, how the body fights and its prevention. First defence. The first defence is the skin. This is the largest breathing organ on the body and it works as a waterproof mechanical barrier and it does not allow any bacteria to enter the body. The only way that the bacteria and the pathogens can enter the body is if the skin is broken and they enter via a cut. Tears, mucus and saliva are also a great way of the body's first defence of capturing pathogens trying to enter the body, also many bacteria. In regards to mucus, this sticks all of the bacteria, pathogens and virus trying to enter the body. Tears and saliva tends to break down any bacteria and pathogens of the pH levels. With the tear duct, it simply expels out of the body where it would be entering the eyes, nose or mouth, which are obvious points for pathogens to enter. Saliva, tears and mucus also contain an enzyme that breaks down the cell wall of the many bacteria. Cilia. Now, cilia is a very fine hair which lines the windpipe. Now, the windpipe, it moves and traps the particles away from the lungs. This can include both dust and smoke. Stomach acid is actually stimulated by the histamines which are released. The stomach acid kills bacteria and parasites that have been swallowed, preventing you from getting ill. This can include regulating the stomach's pH balance, and this keeps it below 4.0. Anything above 4.0 can allow and aid the bacteria to grow. Next slide. Urine flow. Now, the urine flow is a water-soluble phase of which is actually phase 2 from the liver. This expels toxins from the liver, kidney and the rest of the body called urea. Now, urea is a protein found when you mechanically break down meat, poultry and some vegetables. When it's broken down, creates a toxin called urea. Now, urea goes through the urethra and is expelled by the bladder as urine. Next slide. We'll now move on to the second line of defence. Infection. If pathogens are able to get past the first line of defence, for example, through a cut in your skin, infection develops. This is where microorganisms, in regards to bacteria, fungi or virus, try and kickstart the immune system to fight through the bacteria which is invading. This usually creates irritation, redness and expels pus. Usually the only way to fight off an infection is to be taking a course of antibiotics. Next slide. Inflammation. As you can see from this diagram from Very Well Health Centre online, causes of skin inflammation can be heat rash, autoimmune disease, infection, allergic reaction, sun damage and photosensitivity. It is induced by tissue damage due to trauma, noxious compounds and microbial invasion. The process of inflammation is mediated by immune cells, important cells signaling proteins called cytokines and other small molecules. Obvious signs of inflammation is redness, itching, tenderness and swelling. Usually this can be controlled by an antihistamine due to the release of histamine, serotonin and prostaglandins, which binds specific receptors and endothelial cells. So antihistamines are the best way to help with an inflammation. Next slide. Fever. Fevers can strike in both adults and children when the body's homeostasis level from 30.37 degrees is exceeded to 38. Anything at 38 and above is known as a fever. So a fever is the body's way of raising the body temperature to fight off virus, and can include a high body temperature, shivering and chills, fatigue and sickness. And within children can be slightly more dangerous and can actually include convulsions and hysteria. Usually a fever can be controlled by Calpol in children and taking paracetamol in adults with plenty of rest. Next slide. Macrophages is a white blood cell which helps to destroy any debris caused by any bacteria, viruses, and it protects your body from harmful invaders like bacteria and viruses, and eats all of the bad bacteria which may prevent you from becoming poorly. Next slide. The body's third defence. Third defence includes acquired immunity. Although you're born with cells, your immune system gets stronger throughout your life as you're exposed to more germs, building antibodies, and they're called acquired immunity. A good example of this is the coronavirus pandemic, where many people acquired immunity developed when they got the virus, which then allowed the individual to not have to suffer with coronavirus afterwards. And a good example of this is also chickenpox as well, where young children develop the virus, get chickenpox, and this gives them a level of immunity throughout life. If they do contract it, it will only be a mild case. Next slide. Sensitivity to antigens. This means your immune system reacts to a substance that is usually harmless and can cause allergy symptoms or hypersensitivity. Your immune system can become sensitised to an antigen after the first exposure and then produce a stronger and faster response to the next encounter. This has caused the primary and secondary immune response, including B cells and antibodies. Next slide. Different types of immune cells. Lymphocytes. There are two types of lymphocytes: immunity cells, T cells, which controls your body immune response, directly attack and can kill infected tumour cells. B cells make antibodies, which are proteins that target virus, bacteria and other foreign invaders. Next. Macrophages and immunity. We have touched upon this already, but a type of white blood cell that are part of your body's defence mechanism and also part of the immune system in asthma, made in the bone marrow. When foreign invaders such as bacteria enter the bloodstream, macrophages secrete particular substances to help kill the bacteria. Neutrophils are a type of white blood cells that help you fight off infection. If there are too many neutrophils in your bloodstream, you can develop leukocytosis, a high total white blood cell, and there might be symptoms of fever or recurring infection. Immunoglobulins, also called antibodies, are molecules produced by white blood cells that help your body defend against infections and cancer. Their primary function is to bind foreign cells like bacteria and virus. This binding helps neutralise the foreign cell and signals your white blood cells to destroy them. Different types of immune type cells. Self-recognition and tolerance to its own tissues has the capacity of the body to identify and tolerate its own tissues. A crucial characteristic of the immune system helps to guard against the body being attacked by its own cells. The immune system can identify and not react against self-produced antigens known as the self-tolerance. Next slide. Moving on to rejection of transplanted organs. For organ recipients, rejection of the new organs is a significant issue that requires frequent monitoring through blood monitoring and medication. Rejection means that the body rejects a new organ because it sees it as a foreign invader, similar to an unwanted infection. The possibility of rejection is often a constant worry for a transplant recipient because of the rejection could mean returning to dialysis treatments or even death due to organ failure. Immune disorders. HIV virus. This is a human immunodeficiency virus that attacks the human immune system. Unlike other viruses such as the common cold, HIV cannot be cleared from the body. It kills the CD4 T cells, which are immune cells that help fight the body's infection. It can be passed via intercourse, pregnancy and sharing needles. However, now can be treated, allowing the individual to become undetectable with symptoms in order to lead a normal life. MS, multiple sclerosis. An autoimmune disease that affects the central nervous system, meaning when something goes wrong, the immune system mistakenly attacks the layer that surrounds and protects the nerves called the myelin sheath. When become damaged, results in messages travelling along the nerves being slowed or interrupted. There is no cure for MS and gets worse over time, usually resulting in a shorter lifespan. The biology of cell disorders. Acquired immunity. As you can see, this is a diagram which we'll now go further into. Next slide. Active immunity. Natural immunity is once you have an infection such as chickenpox or COVID, the body recognises the virus and develops antibodies which will fight an infection if it reappears in the body. Artificial is when you have an infection, a minute watered down version of the virus is injected into the body, allowing the body to create antibodies that will fight off the virus if it was to enter the body. Passive immunity. Passive immunity develops upon receiving antibodies from someone or something else. When a newborn baby is breastfed, antibodies from the mother is passed on to the baby, which helps to fight off any virus that the baby may get. The mother tends to develop the antibodies that the baby may need or require in order to make them better. Artificial antibodies, known as gamma globin, is injected intramuscular as an artificial form of immunity to temporarily boost a person's immunity to fight off disease such as hepatitis A within the first 2 weeks, chickenpox or someone with measles post 6 days if they have not been vaccinated. Next slide. Immune responses and vaccinations. Vaccinations are able to activate the immune system to create memory, creating long-lasting immunity specific to pathogen. Research demonstrates the protective immunity developed naturally and through vaccination may weaken over time. Next slide. Immunological response. The definition by the dictionary is the reaction of the cells are fluid of the body to the presence of a substance which is not recognised as a constituent of the body itself. Immunologic memory provides the rationale for development of vaccinations against microbes such as smallpox, polio, diphtheria and measles that have previously caused epidemics. Vaccine development has successfully managed many infectious diseases, including the eradication of smallpox. Next slide. This is a comparison of the measles infection rate. Firstly, starting with the 1940s infection rates. According to the gov.uk, in the UK alone, 7,868 people died from measles, dated between 1940 and 1968, when the MMR vaccine was introduced. The University of Oxford reports that measles kills 872,000 worldwide people before the vaccination was introduced. Coming down to the current day infection rate from 2000 to 2020, gov.uk have reported 8 deaths in the UK. The University of Oxford reports that in 2018 there were 966 cases of measles in the UK, 4 times as many as the total confirmed in 2017, which is 259. The majority of people with these cases were not vaccinated. Measles was a highly infectious virus disease which can lead to a serious complications such as pneumonia and encephalitis. Once the MMR vaccination was introduced, the death rate dramatically reduced. Public Health England estimates that 20 million measles cases and 4,500 deaths have been averted in the UK. Next slide. Herd immunity, as quoted by the Very Well Health, when new disease strikes, our bodies have no protection or immunity against them. As people get sick and recover from these diseases, they develop immunity that can help keep them and others from getting sick again. Herd immunity, or community immunity, is based on the idea that more people develop immunity to a disease. They help prevent the spread to others who are more vulnerable. Next slide. Vaccination programs. These programs aim to achieve herd immunity by vaccinating a significant proportion of the community. Once enough people have protection from a disease causing pathogen, the transmission of this pathogen rapidly declines, providing herd immunity which prevents and protects people who have not yet received the vaccine. Herd immunity is a very powerful effect that can dramatically reduce the incidence of even extremely contagious disease, and in doing so, vastly improve public health. Next slide. Factors affecting vaccine uptake. A strong contender is the Andrew Wakefield MMR vaccination link between the vaccination and autism, where a published research study was released in 1998, linking inflammatory bowel symptoms in 12 autistic children to the MMR vaccine. This study, published in the respected British medical journal, The Lancet, launched a massive anti-vaccine movement in the UK and the United States around the world. This was retracted in 2010. This was a study published by Andrew Wakefield in a very well-respected medical journal, which then caused uproar in parents and went on to the eradication, where lots of parents did not want their children to have the vaccination due to the links of potential autism, which has now been retracted and found not true. COVID-19, in October 2020, coronavirus hit the UK pandemic, leading to 3.4 million deaths. This is by the World Health Organization. When conspiracies sparked controversy when the vaccination came out in 2021, this caused a mass divide and prevented many people being vaccinated. Next slide. In conclusion, this presentation has outlined immunity, how the body fights, and its prevention. I hope you have enjoyed it.